That ain't working. Money for nothing. Good morning. I'm impressed not only that you continue to turn out at 8:30 in the morning, but that you do so even on the last day of the conference. The previous keynote speakers have set a very high standard, and I hope that I can be at least in the same league as they are. I think one of the problems in the object-oriented object technology world is that we have been very busy laying sound foundations and trying to put together a class act from the technology standpoint. So busy that sometimes in all this bricks and mortar that we've constructed in our repositories, the human beings get somewhat lost. This is unfortunate because in the end, that's what software, whether it's object-oriented or not, is really about. Now, we have an investment in this because, in truth, this is also one of our biggest problems. In a survey that was done not too long ago, trying to identify the causes of cost overruns. I don't know if anybody in this room has any experience with cost overruns. They found the following interesting information. The number 4 cause of cost overruns was insufficient user analyst, user designer communication. They're not talking with each other. The number 3 cause was, then not surprisingly, a user lack of understanding of their own requirements. So the users didn't know what they needed anyway. The number 2 cause was overlooked tasks. Oh, that's interesting. We're probably overlooking them because the users don't understand them, and not only that, but we're not talking with them, so we're not helping them understand them. Well, what was the number 1 cause? Frequent requests for changes from users, because of course we overlooked some tasks. And that's because they didn't know they needed them. And we weren't helping them figure out that that's what they needed by actually talking with them. Now, that's the situation that we're in the object-oriented as well as the procedural world. What are we going to do about it? Well, we've been punishing not only our end users, but we actually have been punishing ourselves in the process. In my view, the literature of the field has not given us a great deal of help in this process. I did, shortly after I arrived on the scene at the University of Technology a couple years ago, a survey of 15 of the most prominent design textbooks on object-oriented design, published recently, 1992 to 1995. It was a scientific sampling. I took every book from my office and Brian Henderson Seller's office, and there actually were a lot more books, but there was also a certain amount of overlap between our collections. In total, this collection represented almost 6,000 pages worth of material. How much of this had to do with anything concerning users, user requirements, user interface, usability? Well, on those topics, we had a grand total of 161 pages. In fact, more than 3/4 of that was in 3 books, and if it wasn't for Ian Graham's book being included in the sample, it would have been a much, much sorrier picture. Now, counting the number of pages is probably not completely fair, so maybe we should look at things like the total coverage in terms of citations. And if we look in the index of citations to anything with use or user in the title, we find a very similar picture. In fact, there were 5 books in this that had no citations to any of the 12 words that I was looking for. And amusingly enough, there was 1 book that devoted an entire page to usefulness, but didn't think it important enough to index it. That's the situation that we've been in the user interface world in object orientation. Well, why? We've been busy fighting a revolution, and the clouds of war have been drifting over our skies. The methodology wars and then the notation wars. Although we're told that peace has come to our little community, we're now unified. Although there are a few partisans out in the outback who think that the issue may still be open. In all of this, there hasn't been a lot of room for attention to issues of user interface, usability, and usefulness. Now, what are objects all about? Does object technology matter to users? Do they care about it? Should they care about it? In my view, object technology is really a concern with the technology under the hood. It's a question of the valves and what kind of a carburetor and things like that, not the technology on the surface. And in fact, for the most part, we haven't been terribly concerned about whether or not there's even a hood release provided and whether our users can reach it when they need to. On the other hand, I'll have to say that I think object orientation does have something important to offer to our users. Unfortunately, we've been failing, but then again, so has everybody else. Nobody in this industry, I think, is doing a really laudable job across the board. We continue to invent new languages that supposedly give us more power, but it's not at all clear that that extra horsepower is delivering more end utility. We've been punishing ourselves in the process. In my view, object-oriented notation has a relationship to usability because notation is really the user interface of methods and processes. It's what connects us to those methods. And if we take this view, notation should be designed from the standpoint of usability engineering, software usability, making use of disciplines like semiotics, the study of signs, perception, cognitive psychology, and all the complete gamut of techniques that help us to produce more usable systems. Now, that's not, of course, what has happened. For the most part, what we end up with is complex, obscure, arbitrary notations, and no particular models for helping us to design more usable user interfaces. They're all concerned with the technology under the hood. Now, one might think it'd be a good idea to turn some of the experts on software usability loose on this particular issue. Recently, in fact, some human-computer interaction specialists did, in fact, design an object-oriented notation, and it looked something like that. Complex, obscure, arbitrary, with no models for usage and user interface. In fact, it resembles some of the dominant players in the recent notation wars. What are our systems for, ultimately? Why do people ever have software? In the view that we've adopted, all software systems are tools. Whether they're the sort of things you usually think of as tools, like editors and word processors, compilers, and things like that, or whether they're what is commonly called applications. Tools are things that help people accomplish something. And they make that something easier to do, or simpler to do, or faster, or possible in some way. And sometimes they also make it more fun. That's a nice side effect. Unfortunately, we don't necessarily supply the tools in the right form and format if we don't understand the answers to certain questions. Like, what are users doing? What are they trying to accomplish? What is it they intend to do and are attempting? And what do they need in order to accomplish it? The result is that we often supply very sophisticated, very powerful software, and perhaps with very elegant, very appropriate class models, but not necessarily the tool that fits what it is users are trying to accomplish. So we never get around to this question, how do we supply what it is that users really need? Now, this has something to do with object-oriented user interfaces, or UIs, as they've come to be called, or if you really want to be correct, UI GUIs. What is an object-oriented user interface? The term has been around for a long time, and a number of attempts have been made to define it. Some people say it's an interface of any system implemented in object-oriented programming. Some would narrow it and say that the user interface itself actually has to be implemented in object-oriented programming. Both of those, again, focus on the technology under the hood rather than the actual user interface. So some people will say object-oriented user interfaces are interfaces involving icons, toolbars, pop-up menus, point and click, drag and drop, the icky sticky ooey gooey that has become the legacy of modern user interface design. Except that's the state of the art, whether you're object-oriented or not. So that's probably not what object-oriented user interfaces are about. Some people say object-oriented user interfaces are about pictures of real-world objects because they're also laboring under the illusion that object orientation has something to do with real-world objects. The question of whether or not there is a real world out there, or the hermeneutics of postmodern neo-non-positivism, don't seem to enter into this debate. And the fact that your real-world objects might be different than mine is not at issue. One of the most innovative approaches is the view that object-oriented user interfaces are object-oriented because users send messages to objects. I'll have to tell you, because I spent a lot of time dealing with users, that users do not send messages to objects. The only people who send messages to objects are people who have been engaged in decades of small talk and are suffering from a certain amount of neural damage as a result of that. What users actually do, I like small talk, by the way. I supported it as the language of choice at the University of Technology in Sydney. But that aside, what users actually do is they do things with and to objects. And if you talk with them for 5 minutes, you'll realize they never ever think of what they're doing as sending messages to objects. That, again, is the technology under the hood. Now, Dave Collins recently published a book with the title, Object-Oriented User Interface Design, and he describes the characteristics of an object-oriented user interface. There now, in fact, are 2 books on this subject, so we've vastly increased the total number of pages in the literature. He says that users perceive and act on objects, users classify objects based on how they behave, and all user interface objects fit together into a coherent conceptual model. Well, this is a nice description, but it actually isn't a lot about either user interfaces or object-oriented user interfaces. The first 2 things are really about users, which may or may not be true. And in fact, again, if you actually talk with users, you'll find sometimes they classify things on the basis of behavior. Trevor, stop acting like your younger sister. And sometimes they classify things on the basis of appearance. Oh, you look just like my cousin. So that's not really the issue here. And the third thing is actually about good interface design, whether there are objects involved or not. So we still don't know what an object-oriented user interface is. Well, we can go back to this issue of real-world objects, which play an important part in some object-oriented analysis schemes, and look at the state of the art in user interfaces based on, quote, real-world objects, unquote. Here's an example. Actually, this is a very old simulation that I revived recently. Years ago, I said, if the current trend continues, somebody someday is going to do something really stupid like this. You have a personal information manager based on an object metaphor that has been brought to the user interface like a Rolodex. and all you have to do is click on it and it opens up. And if you want to roll through the things in the Rolodex, you just click on the knob. In fact, you might even be able to drag the knob up and down. Well, I'm sorry to say the world has progressed, and there actually is a product out there now based on this technology. What's wrong with it? What's wrong with it is a Rolodex is a very usable object when you can actually pick it up and hold it in your hand. You can rotate that knob very quickly in either direction. You can stick your finger in one place and flip to another card. It makes sense as a physical unit. When you try to simulate it on the screen, it not only becomes silly, but it slows you down. It's a lot less efficient than just scanning through a list of things. So what we often end up is not usability, but silly, simplistic simulations of these real-world objects. And again, we can't blame this on the object-oriented world or object technology. It's in part a misunderstanding about what software systems are really for. A more familiar and ubiquitous example is the idea of the notebook metaphor, which of course, as processors become more powerful, becomes animated. Well, unfortunately, metaphors, although they can sometimes be useful to help users make sense of our systems, they also can be limiting, and animations can be annoying. In this kind of a metaphor on the desktop for a personal information management system, we have a complete representation of a day timer or a day runner or some other kind of pocket personal planner, even to the tabs, which if we click on them, we can flip the pages and go to a particular section of the notebook. Don't pay too close attention to the fact that people who use these for an extended period of time end up with whiplash from trying to read the labels as they flip back and forth. The really nice thing is one of the best known of these products has the wonderful feature of allowing you to delete something from your notebook by dragging it to the wireframe wastebasket, where, just like in the real world, it bursts into flame. Now, the actual product, which I'm not showing you here, and which will go nameless, has a much better animation of the flames. I mean, they look so realistic, and you know some programmer, possibly working with a graphics artist, spent days getting that animation just right. Is this progress? In my antique personal information management system, I can delete something by hitting the delete key. Well, what these kinds of user interfaces are is they're Sizzle. They're very attractive. They're appealing to people who buy software, who are not necessarily the people who have to use it. In my view, from my work in software usability, simulating a day timer or a day runner or Filofax or Rolodex on a desktop is a little like those ballpoint pens that you can get at amusement parks. Did anybody pick one up last night? They look like a quill pen. They're made out of plastic because feathers are too expensive nowadays. They're really cute. But the truth is that to get real work done, most of us would prefer something like an Aurora or a Mont Blanc, a real tool. Now, a Mont Blanc has got to be one of the ugliest pens ever developed, but it writes beautifully, and it just serves the function very well. Now, another trend in the real-world object user interface world is the trend toward big objects. If objects are good, then bigger objects must be better. I call this the bonanza of blobs and big bozo bitmaps. The resemblance of this little simulation to anything you've ever seen is, well, we're trying to protect the innocent. Many of these things mix a kind of user-over-friendly approach to dealing with users at the user interface with a smattering of geek speak. So we're greeted by the friendly, "Hi, let me help you duplicate anything, anytime," and then it goes on to say, "Just choose the mode and click on the control." Actually, I don't see any control, but all right, I'll try something here. The systems reduce an interaction with the system to tiny, tiny steps. In fact, so small that we can't simply straightforwardly accomplish anything. We have to first tell the system what we're going to do, in which case then it changes mysteriously. And those of you who understand usability principles know that one of the things you don't do is have something that was once a hammer suddenly become a saw. And you may in fact have missed the fact that when we clicked on that radio button, the control button actually changed. When we finally have told the system what we want to do in one step, we can then make it, oops, you have selected a non-safe mode of duplication. Don't you love messages like this? You have no idea what it means. You may sit there and puzzle it out if you're highly motivated. Then again, you may not. What I really want to do is I want a button that says, "Not okay." No? No, tell me something else, do something else, stupid. My father was a mechanic, and he taught me a lot of techniques for repairing equipment. He always told me, don't ever force it. Get a bigger hammer. So these are what I call equal opportunity interfaces because they annoy everybody equally. Unfortunately, it seems to be an important trend in user interface design, and we're seeing more and more consumer products, and it's beginning to pop up even in some of the tools that we as developers end up having to use. Now, are there any good real-world user interface objects, or are there any times when we really would like to surface the technology under the hood and offer it to our users? Well, there may be, and this is a topic we could spend a lot of time discussing, but here's one possibility that sometimes might make sense. It might make sense, for example, to externalize, to bring to the surface the factories or constructors for some of our classes of objects in such a way that when the user clicks on them or swipes them or drags them, they instantiate instances of those objects. For example, this might work in some applications to have a simulated pad of fax cover sheets that could be used to open a new fax cover sheet and eventually launch a fax transmission when you drag and drop. From the user's standpoint, however, this doesn't actually necessarily represent a great world-shaking advance in technology. It does fit the current document-centric trend in user interface design. I love this word centric, which appears everywhere. It's not in any dictionary yet. I think we use it because it sounds big. The truth is that from the user's standpoint, this kind of factory object is not much different from having a fax cover sheet tool or fax cover tool, or even Control-N or File New as a way of accomplishing the same action. And in fact, if you look at it very closely, it's about the same number of motor steps and operations that are needed no matter how you do it. Now, there may be some possibilities where big bozo bitmaps are in fact justified. Here's just one example. When I first saw this, which is sometimes called the virtual office, this particular bitmap appears in a product called Managing Your Money from Mecca Software. I thought this was really, really bozo. They said it would be very familiar and comfortable to you. Well, I haven't worked in an office with a big oak desk like that and a quill pen in many years. What this user interface mechanism does is it provides objects that actually allow you to accomplish actions. Turns out the quill pen is for printing checks. And all of the objects on the bookshelf, in fact, are different repositories of information. Some of the objects are very amusing. You click on the statue of the thinker if you need help. And if you experiment, you find that there are all kinds of objects in this room that are active, including the mouse hole over in the corner, which is how you exit. I suppose that's for users who are real rats. Now, the documentation for this particular product when it first came out said, this is so intuitive, you'll immediately feel right at home. All you have to do is click on the checkbook to pay the bills and click on the scales to balance your checkbook. I was delighted to read that because, you know, I realized I'd been doing it wrong all these years. I had been using a calculator, and I went right out and got myself an old-fashioned beam balance scale. Actually, there is an advantage to some of these seemingly silly kinds of similes because they have a tendency, once you know them, to stick in the mind. I've offered this wager to classes for some years now. I'll bet you 5 years from now we could meet and I could say, so how do you balance your checkbook with managing your money from Mecha Software, and you'll remember. The really intriguing thing about this kind of user interface, which on the surface seems like another example of the artistic silliness we have to put up with, is that they actually did usability testing and found out that the people who liked this and made the most effective use of this were actually power users. People had been using their products for a long time and were now trying out this new version. Why is that? Well, it's an interesting thing. What this kind of big bozo bitmap provides is a flat hierarchy with one central dispatch point and immediate access to everything. In a sense, it's the visual equivalent of the C prompt. You know, where do you want to go today? You can go anywhere. I'm sorry, where do you want to go today? Registered trademark. You can go anywhere. It provides, however, one additional feature. It provides objects in a context that is highly differentiated visually, so that it's easy to remember where things are. As such, then, it's a lot simpler than the 43-button toolbar that you'd have to use in order to provide an equivalent degree of access to all this functionality. So it ends up supporting fast production use by experts. And in fact, the only secret code you have to remember is what is the escape sequence that you use to get to this central dispatch point. And after that, it just tells you, it reminds you visually. It's very easy to learn and to remember, and even beginners like it. But is it object-oriented? Well, actually not. This was written entirely procedurally. It could have been object-oriented. Another thing that has been coming along as a trend that may well help us to produce more usable software is visual development. Visual development actually started in the procedural world with Visual Basic, Power Builder, SQL Windows, and others of the early visual development tools. Of course, all of these tools now claim to be object-oriented, and many of the object-oriented languages now have visual development tools based on them, things like Visual Smalltalk, Visual Age, Borland's Delphi, and the like. What visual development tools allow you to do is more quickly and more easily create user interfaces and working prototypes. And some of them are becoming complete environments that allow you to produce full-fledged industrial strength applications and software. The model for this is programming through visual objects, programming by manipulating interface widgets and other objects on the screen. The really important operant word there is visual. Visual development is visual. So that means it's not the same as having a really good package or library or set of foundation classes for interacting with user interfaces. And when you change the mode of development to actually allow you to think in terms of the visual placement and visual relationships among objects, it not only accelerates the process, but potentially it allows you to produce better results. This facilitating of visual thinking and direct layout, however, has a downside. It's so powerful, it's so quick and easy to use. All you have to do in many of these tools is grab a widget off of a palette and drop it onto the form or screen that you're building in any order, whatever order you happen to think of things. And then sometimes you may take the time to actually do some alignment or other aesthetic tweaking. Interestingly enough, these tools, some of them have only recently provided the extra functionality to make alignment and this aesthetic tweaking easy to do. And in the process, then what happens is the user walks in the room and says, "Oh, that looks good, I'll take it." And the result is nobody, users or developers, is really paying attention to the overall organization or even some of the important details about the user interface. Things like workflow. What is the relationship between the order in which things appear in the user interface and the order in which they are needed in the tasks? The semantic grouping. Are the things that appear together things that people think of together, or are they unrelated? The choice of widgets. Maybe I should have used checkboxes here instead of radio buttons, but I didn't have time to think about it, and not only that, but it works. So the arrangement of the visual objects, how they behave, which is an important aspect of usability. And the result is a user interface that people say, "Oh, cool," but in fact may not be particularly usable. So how do we go about delivering usability to our end users and our customers? Well, the standard approaches are usability testing, standards and style guides, prototyping, and the use of human-computer interaction experts and specialists. Each of these has some real potential payoffs. Usability testing gives us some objective measurements, some empirical results, numbers that we can take to managers and to marketing, and it's based on established methods. This is probably the best developed of all the approaches to user interface improvement. Standards and style guides allow us to potentially produce more consistent results given proven, already worked out approaches. Prototyping is a practical, efficient way to accomplish user-oriented development. You throw something together, you show it to users, you go back and you make some improvement and so on. And experts, of course, are the ones with the experience. And in fact, the use of experts turns out to be, by the actual studies, cost-effective, because it turns out that the informed judgment that they offer us is an efficient way to figure out how our user interfaces are best improved. All of these also, however, have some downsides and limitations. Usability testing tends to be relatively costly. It's also something that by definition comes relatively late in the process. To really test a piece of software, you have to have a piece of software to test. If not an alpha internal release or a beta release, at least a darn good simulation. The other thing is, it often misses too much. It's just like testing in getting bugs out of the software itself. You can't test your way to quality. You can't do enough testing to cover all the possibilities. Standards and style guides are good, except that the work of a colleague of ours in Boston, Jared Spool, has found that typically, even when you take standard published guidelines like the Microsoft, Apple, IBM, Sunsoft user interface guidelines and combine them with specialized corporate guidelines, you still only answer about 10 to 20% of the questions that come up in the course of real everyday development. Prototyping, unfortunately, oftentimes becomes a replacement for design and for thinking about things, and it isn't that. It's not a substitute for thinking about your problems and making careful, deliberate decisions. And with HCI experts, the problem is there just aren't enough of them to go around. The vast majority of developers do not have a usability specialist to sit next to them and look over their shoulder. Most companies and most groups don't have access to usability testing and expertise, or only have limited access. So there's just not enough to go around. Besides, as we found in our investigations, most of the decisions affecting the shape of the user interface and impacting on the usability of the end product are being made by the developers, like you, and not by experts. So, what are we going to do about this? We think that there has been, over the course of many years, a shift in the focus of the development process. And in the long term, this is continuing in the right direction. It started out with our attention fixed almost entirely on the code and computers. Back when I first learned programming at MIT in 19... nobody talked about user interfaces. There was no such thing. You submitted jobs in stacks of punch cards. Some of you probably remember punch cards. And a day, or sometimes two later, you got back a printout. As the systems got more powerful and allowed us to do more things, we began to shift our focus more on what kind of functionality we delivered and what kind of features we supplied. And eventually, this attention brought us out to the user interface. Now, user interfaces were discovered by our field long before they were graphical. As soon as the first terminal was attached to a computer, even the old Frieden Flexowriter kinds of terminals, there began to be a concern about user interface. But you'll notice that all three of these things are really technology-centered. They're focused on the software itself. They don't really look outward. Eventually, some people in our industry discovered that on the other side of the screen, there was a real person, a user. This made us profoundly uncomfortable. I mean, most of us would not be in this business if we weren't basically geeks at heart. We like talking to machines. Now, some years ago, I would have said, no, I'm not a nerd. I mean, I have a degree in management. I have a license as a marriage and family counselor. I'm a people person. Well, my partner, Lucy Lockwood, disabused me of that illusion one time when she went into my desk looking for something, and she saw that there was something in there, and she said, "What is this?" And I said, "Well, it's a screwdriver." She said, "What's that thing next to it?" I said, "Well, that's a straight-bladed screwdriver. This is a Phillips head screwdriver." And she said, "And what's that weird thing next to it?" And well, it's an IC puller. And she said, "What are they doing in your desk?" Well, that's so in case I have to take the back off the computer and swap chips. She says, "That proves it. You're a geek." So now I'm proud of it. Well, what do we do? What do we geeks do when we encounter real human beings? We're a little uncomfortable with the situation, so we get friendly. And user-friendly software was invented. This is the stuff that, you know, when you sit down at the terminal, it starts off with a message. "Welcome to the XSys system. Please log on by typing your full name." So you type in, "Welcome back, Larry Constantine. It has been 7 hours and 36 minutes and 24 seconds and 14 hundredths since we last saw you. Please type your secret password." "Oops, I'm sorry. You must have made a mistake. Try again. Be more careful this time." Now, user-friendly software didn't last long. because it's not really a good idea. Unfortunately, there are some young people up in Redmond who didn't get that word. And so now we have Bob, or as we call it in Australia, Bruce. User-friendly as an approach to software development was replaced fairly quickly with user-centered development. User-centered development says users are the heart of the whole matter, so let's put them at the center of the development process, make them the primary focus. In the most extreme forms of this, in participatory design approaches, you actually invite them to move in with you and become part of your software team. User-centered, per se, did not last long either, for a different reason. The thing is about user-centered is it doesn't sound all that interesting. It sounds like something you could learn about in 5 seconds, and it's very hard to sell books and courses on it. So user-centered was quickly replaced with user-centric. And this is a safe term because when your boss looks up centric in the dictionary and doesn't find it, he or she concludes that it must be something worth learning about. And they'll authorize the $900 for you to go take a course. Fortunately, user-centric as a point of view is also becoming less popular, and we think it's being replaced by another approach, which we call usage-centered design. What's important in usage-centered design is not the user as a person or the user as a specific user, but for the way in which they're making use of our software. And by focusing on this usage, we have a chance to deliver software that is substantially better. Now, usage-centered design not only sounds too much like user-centered, but it doesn't sound like something you'd have to go to school to learn. So we also have another term for it, which is teleocentric. Now, that is in the dictionary, if you have a big one like the Oxford English Dictionary. And what does it mean? It means purpose-centered or usage-centered. So if you go back to your companies and institutions and people ask you, what did you learn at OPPSLA? Besides learning about patterns and ethical challenges and things like that, you can say that we learned about teleocentric design. Now, how does this contrast to the tools that we have available to ourselves? What is the central metaphor on which all of software engineering and software development has been based almost since its inception? It's the classic software engineering metaphor of a black box. Who did that? These cards are everywhere. The black box metaphor is interesting. A black box, of course, is a box you can't see into. And we have all kinds of things related to the black box metaphor, encapsulation, information hiding, things like that that are at the heart of object technology. But what are the typical models that we use to design systems that are supposedly based on this black box metaphor? Well, there are things like the data flow diagram, structure charts, entity attribute relationship diagrams, Hirel charts, event models, class hierarchies, object communication diagrams. What do all these things have in common? All of the intention is focused inside the box. And so for the question of, what color box do we supply to our users, we give the same answer that Henry Ford did back in the early days of the automobile. You can have any color you want as long as it's black, because we're not even looking at the outside. Now, usage-centered design brings some new models to this process that help us to pay more attention to what it is we actually supply to the user, what it is that they see. We use these models to answer questions. We don't do modeling because we like to build models. No, we like to build software and supply things to people, and that's ultimately what we get paid to do. We use these models to answer questions like, what kind of users are going to make use of this system? What is it that they're trying to do? What do they need in order to accomplish it? And how are they going to do it with the system that we're building? For each of those questions, we have a different modeling approach. To answer the question of what kind of users, we use a user role map, which represents relationships between classes or kinds of users and the system we're trying to design. To answer what are users trying to do, we use use case models, which represent the essential structure of the usage by those users. To answer the question, what do they need in order to accomplish it, we have the use context model, which represents the materials and tools that they will need to complete the task. And for the question, how are they going to do it with the system we're building, we have a navigation map, which shows how they negotiate their way through the features that we supply to them at the user interface. Now, these first two models are concerned with usage, and the second two models are concerned with architecture. Now, I'm a fanatic about citation. My partner says I'm actually compulsive-obsessive about it. So the main citation on usage-centered design is Constantine and Lockwood. How'd that slide get in there? The heart of this approach to usage-centered design is the notion of abstraction and abstract models. This is a concept that should be very comfortable to all of us in the object-oriented world, because object orientation is based on the idea of abstraction. What abstract models do is they give us a way of looking at things that's actually simpler than the real thing. And in this way, they allow us to avoid messy and distracting detail, and we can defer decisions about how we fix those details. This means that we can focus our attention more on the whole, on the broad picture of the software, the user interface, and in these particular models with a particular emphasis on purpose and intent. The other thing that abstraction and abstract models do is they invite innovation and encourage creativity. As Stephen Sondheim said regarding the French pointillist Georges Seurat, his favorite color is white. It represents a blank canvas or piece of paper, which has so many possibilities. And the intriguing thing is that we found as developers and designers get more experience using abstract models, they open up new possibilities for creative innovation. Good. So I want to take a brief look at some of these models. Obviously, we can't do a whole tutorial here, but to give you a little bit of a flavor of what this approach to what objects are all about might be. One of the models is the user role model, which is a focus on the relationship between users and systems rather than on the users per se. Ivar Jakobsen, when he first introduced this concept, referred to them as actors. A role is an abstraction. It's not a person, it's a relationship that is played by some group of users. And as Rebecca Worf-Sprock calls it, it's a collection of interests, expectations, behaviors, and responsibilities. All of those have to do with users, but they're not the user themselves. For example, I use a word processor. I'm a geek, but I'm also a real human being. I use the word processor in different roles. Sometimes I'm using it in the role of a writer, in which case one of my expectations is for the system to just get out of the way and let me type as fast as I can and get my ideas from here into there. I don't want a lot of functionality, and I certainly don't want little pop-up things that tell me what's going on or that I've misspelled a word or something like that. On the other hand, when I'm an editor, I'm interested in exactly how the sentences are constructed, is the spelling correct, rearranging paragraphs, things like that, and I have a different expectation for what tools and materials the user interface should supply to me. I also sometimes am operating in the publisher role, and in which case I don't care what the words say. Most publishers don't. What I care about is what is the arrangement on the page? How does it look? How does the text flow from one column to another? Where are the breaks? How does it relate to the position of the pictures? Things like that. This is one piece of software, one user and different roles with different expectations. Now, the user role model is not something really elaborate. It's just a list of user roles described by those characteristic needs and behaviors. The heart of what we've been doing is something called the essential use case model. Now, an essential use case is an abstract case of purpose-directed usage. Citation, Constantine and Lockwood. It's idealized, it's technology independent, and that's why it's called essential. And there we're drawing on the work of Steve McMenamin and John Palmer, whose classic book, Essential Systems Analysis, is probably the definitive work on the subject. Now, this is an extension, and we think a very important departure from the notion of use cases as developed in object-oriented software engineering, which, of course, is Ivar's work. An essential use case and use cases in general represent the external black box view of supplied functions. Something that's complete, that's something that's well-defined and makes sense to the user. An essential use case, however, is concerned with the purpose, not the concrete steps or mechanisms. It's about what a user in a role is trying to accomplish, rather than how they're going to accomplish it. And it's simplified and generalized. What exactly is it? It's a structured narrative that's cast in the language of the domain or the user. It consists of three very simple parts: a name and essential purpose, and sometimes the name is enough to capture the essential purpose, and a two-column dialogue. This is an innovation introduced by Rebecca, and we also think it's an important innovation. It organizes the use case. It divides up things that are fundamentally different, the user actions and the system response, and that line down the middle is the system boundary. It actually represents, metaphorically, the user interface. Now, the thing about this model is it's a very good way to communicate and negotiate with users. And what makes it so good is there's nothing for them to learn. There's really no notation, there's no conventions, there's no logic or obscure relationships for users to have to learn. All it is, from their standpoint, is a simple conversation of the he said, she said, she said kind of variety. And they don't have to be trained. They fall into using them as a way of communicating with analysts and developers quite naturally. What's an example of this? There are a few archetypal applications that tend to show up over and over again in papers and books on object orientation. One of them is using an ATM machine, an ATM. From the standpoint of the essential purpose, this use case is getting cash. Why? Because that's the most common transaction at ATMs. Now, for the ATMs at my bank in Australia, the use case looks something like this. It starts with me inserting a card. The system response is to read the magnetic stripe on the card and request my personal identification number. I enter my PIN on the keypad. The system verifies it and displays a menu of options. I press a key of cash withdrawal. It displays the account menu. I press a key to tell it which account I want. It prompts for the amount. I enter the amount. It displays it and requests me to verify it. I confirm the amount. It then returns my card. I take the card, and finally it gives me the money. Now, what does this have to do with getting the money? In particular, in order to look at this from an essential standpoint, from the standpoint of purpose, teleocentric, we're interested in the question of why. Why would a user do any of these things? Why, for example, would I take something valuable like my ATM card and stick it into a slot in a wall, knowing there's some chance I might never see it again? The bank even tells me, guard this as if it were cash. Well, I'll tell you, I never stick cash in a slot in the wall. So why am I doing it? Well, what this is all about is I'm trying to identify myself in a way that the system understands. I'm concerned about that, not because I particularly want to insist on making withdrawal from my account. As far as I'm concerned, I'm perfectly happy if the bank gives me your cash. But I'm acutely dissatisfied if it's the other way around. And you would say the same thing. So all of us as users in that role have a collective interest in identifying ourselves. For the same reason, we want the system response to be to verify that identification. We want to make sure that the bank knows that this is, in fact, indeed the person to whom I'm speaking. Now, what else do we expect from the system? Well, I'd like it to offer choices, because I don't always do the same thing. However, one of the choices I would like it to offer me is the usual, Mr. Constantine. The thing is, the bank and I both know that almost every time I take out cash, I take out the same amount. Those of you in the banking industry know that typical ATM transactions, 80 to 90% of them are cash withdrawals, and 80 to 90% of those are for exactly the same amount the user took out last time. Now, the bank has this on file. They know what it is. Why don't they offer it to me? In fact, why can't I just hit one button, the top button, and get what I want? Or just do one thing, or just nod and say yes. Or for that matter, of course, stupid. So I make the choice, and then I take the money that the system has given me. Now, you will notice this is a lot simpler on the right than on the left. The difference is, by focusing on the essential purpose, we distill the use case down to its bare essence, the central core of what it is the user is trying to do. In the process, we've opened up many possibilities. Years ago, when I first started using this example, I suggested, among other things, you could use retinal scans to identify your users. Why you have to have them carry around a card with you? I mean, you can just put your eye up to the slot and that's it. Or if it's a good camera technology, they can, stabilize the image and zoom in on your eye and so forth. Everybody laughed. Well, the amusing thing is that they're actually doing that now. There are trials in Japan and the United States of ATMs based on retinal images. There are lots of other techniques. The system could recognize your voice by voice print analysis. It could ask for a thumbprint. For that matter, it could look at you and say, "Aren't you Mr. Constantine? Don't I recognize you?" So essential use cases open up many more possibilities for simpler, more straightforward ways from the user's standpoint of providing these services. Now, some people have sufficiently warped minds so that they think in abstractions. I won't completely own up to this, but sometimes I do. But most people, in fact, are more comfortable thinking in concrete terms, and so they start off with a concrete scenario and then simplify and generalize it. And that's a perfectly acceptable way to get at these essential use cases. Now, another term that you'll hear a lot in this area, both in object orientation and in user interface design, is the word scenario. And some writers even use the word scenario to replace the word use case, which some people find a bit unfelicitous. But in truth, there is a difference between scenarios, as usually used, both technically and informally, and use cases, and essential use cases. The difference is like this. Scenarios are intended to represent some kind of typical interaction, but they're cast in concrete, very specific terms. Perhaps we're designing a system to partially automate the technical support, the help desk facility. And so one of our designers says, okay, here's the scenario. It's 4 a.m. and Ian Smith calls a tech support line. There's nobody on duty. He gets the please enter your customer ID prompt and keys in 176820002 on the telco keypad. Now, all of it is very specific, but none of us would be so naive as to think that we're only going to support customers named Ian Smith, or that the system will necessarily be optimized so it'll only perform completely at 4 a.m. No, those are intended to be representative kinds of things. The problem with scenarios is that scenarios do not make clear what part is intended to be representative and what part is to be taken literally. A use case, on the other hand, represents a generic scenario. It's a specific interaction, however, with a given user interface cast in generic terms. The use case in this particular example might read something like, customer calls tech support, here's the prompt, keys in ID. Now, there are a lot of assumptions still built into this. It assumes that the primary mode of output from the computer is audible. They hear the prompt, and that the user is going to key in their ID on the telephone keypad. What would the essential use case in this case be like? Well, an essential use case is a generalization of use cases that represents abstract interaction based on purpose or intent. The user asks for help and identifies themselves. Now, the differences here are very important. The difference between the first two, scenarios and use cases, is exactly the kind of thing that all of you who program would appreciate immediately. It's actually the difference between writing something in literals or constants and writing something in variables. And essential use cases are an additional level of abstraction and generalization from use cases. And what that allows us to do is to design simpler, better, and potentially more creative and innovative user interfaces. The last abstract tool that I'll just briefly describe is something we call the use context model. This is an abstract model of the workspaces that users use, a concept that we originally borrowed from Karen Holtzblatt and Hugh Bayer. They call them work environments. It's based on an observation about how human beings normally go about accomplishing tasks. They tend to do them in specific places or with an array of specific tools and materials that support that work. So if I want to change the oil on the car, I don't go into the kitchen, I go into the garage. I don't get out a ladle and a pot, I get out cans of oil and a wrench and things like that. If I go into the dentist and the agenda for the day is an abstraction, an extraction or an abstraction, what's arrayed on the tray by the assistant or the hygienist is a very different set of tools and materials than if the agenda for the day is a routine cleaning. This is so ubiquitous about how we carry about tasks that it's something that only academics would ever even think about. So the use context model is an abstract way to represent those tools and materials that would be needed to support the work as represented by a particular essential use case. It's nothing fancy. We do it by laying out Post-its on paper. The result is something that some of our colleagues refer to as a low-fidelity prototype, because it looks like a prototype for screens and dialogues and things like that, except not very well drawn. The widgets don't look like widgets. Now, we think this actually misses the point of it, because it's not a low-fidelity prototype. It's actually a high-fidelity abstract model that allows us to work through key questions in the organization and architecture of the interface without having to draw or decide on details of exactly what those things are going to look like or how they're going to be arranged. Ultimately, of course, this guides the layout of an actual user interface prototype. Now, I haven't said anything about users in this process directly. I've talked about models that help us to understand what they're trying to accomplish and how we're going to support it. The problem of users in development has been with us for a long time, all the way back to the traditional software development lifecycle models, which were sequential based on a series of steps or phases, what has popularly been called the waterfall models. And these models are aptly named for that cold, icy splash at the end. where you suddenly realize, oh, I'm in deep water and I don't have a paddle. Of course, we've gone beyond that, and now we have a variety of modern recursive, iterative, gestalt, translational, and concurrent engineering models. Here's one example that comes from Ian Graham. He calls it SOMA. The question, however, is still, where are the users in this process? And if we look for them, it's hard to find them. There they are. This particular model I picked because it actually has explicit reference to an activity called user review that could occur many times. On the other hand, in practice, very often users are still viewed as problems. Why? Well, because we don't know how to talk with them, they don't know what they need, we're going to leave out requirements, so anytime we see them coming down the hall, it probably means they want something more or they want something changed. And in most of the modern software development lifecycle models, there's just no attention to user interfaces except as a technical detail or an aside, as in most of those books on object-oriented design. Now, object orientation has offered a promise for a very long time, the promise of seamless development. This promise also contains some problems. It begins, again, with that wonderful real world, whatever it is, and moves through a process of more or less object-oriented model building, and eventually produces object-oriented software. In the idealized view, all of this is one smooth process without distinct phases or steps or disconnects or changes of point of view. In the ideal case, what this allows is us to use the vocabulary of the application domain and of users and embed that into the software in such a way that that vocabulary is a consistent way of communicating not only with users and with each other, but also with the machine. There's still the question of where are the users in this process? Do we talk to them at the beginning in order to learn their language and then dismiss them? Or do we invite them in and give them an office? How do we do that? Well, here's a flexible alternative that could be called usage-centered. One way of looking at this, consisting of a number of activities focused on modeling what it is users need and are trying to accomplish. Some activities involved with developing initial versions of systems, some activities involved with fitting those to the real-world context, some activities involved with producing the software that will actually be used, and ways of improving that. Now, how this differs from the more traditional models of software development life cycles is it consists of a collection of overlapping and concurrent activities, which in many cases can actually be reordered to fit the needs of a particular development project, or reordered in some cases dynamically as the needs of the project change over time. It's model-driven, and what in fact is the core model is the essential use case model, which drives the structure of the user interface architecture, it drives the object-oriented design process, it drives the construction process, and it drives the inspection process and testing process. It's also usage-centered. At the very heart of it is these models of essential usage. And it's user-involved. Users play a role in collaborating with the development team at key points, at those points where they are most needed and when they can be of most help. All right, where does this leave us? If we want to produce objects as if people mattered, then there are some things that we need to do. First of all, I think we need to integrate usage, what it is users are trying to accomplish, and usability, how well we support that, as a continual and primary concern throughout the object-oriented development process. Secondly, I think we need to incorporate user interface design with a special object-oriented twist to it as an explicit activity within our methods and methodologies, not as a side issue, not as a peripheral concern, but as something very important and central in the process. Third, I think we need to find innovative ways to express objects and object technology and the object-oriented metaphors at the interface, not in ways that we think are clever, cute, mathematically elegant, but in ways that are driven by the real needs of real users. What does that mean? Well, we're only going to understand those things if we involve users in some way appropriately as collaborators in development. Now, it's rather shocking to think so many decades into the evolution of object orientation that we're just now getting around to really be concerned about that. But the truth is, object orientation started out with developing things to serve us. So we were the users, and we understood the problems and the issues. And as object orientation moved out and began to address the patterns of and problems of the rest of the world, we had to pay more attention to those issues. How do we do this? Well, we need to understand from users, through their involvement, their intent, what they're trying to accomplish, their goals or purposes, the roles that they will be playing in relationship to our systems, the vocabulary they're using, the patterns of usage and how those patterns of usage will change, and what they need in order to support that usage. Now, needs are not the same as wants. We jokingly tell our classes that you should never ask a user what they want. The risk is they'll tell you, and they'll tell you whether they know or not. And not only that, the worst question you can ask is, yes, and what else would you like? Because they'll always have an answer. When Microsoft released Word for Windows 7.0, they proudly announced that as the result of the wish line that they had been operating, they had been able to satisfy in the new release some, I don't know, it was 800 wishes. And the user interface looks like it. There are studies of high-end word processors that have actually found that there may be as much as some 20% of the features of the system that no user ever uses, which means 20% of the code might as well not have been written. And instead, what they do is provide facilities at the surface of the user interface that at best just distract users. I think that the empowerment of people in the workplace, includes us as developers and our end users, is an important issue. But from my point of view, in order to empower users, first of all, you can't ignore them. You can't leave them out of your methods, you can't leave them out of your agendas, you can't leave them out of your thoughts. You have to pay attention to them. But more importantly, compared to the traditional notion of user-centered design, to empower users, to really empower users, what you need to do is not to make them the center of your development universe. The important thing is to give them better tools. So in the end, it does become a technical issue, the kind of thing that we as technologists, as geeks, as nerds, are basically concerned with. Now, there are people who think that humanistic concerns are really important. I happen to be one of them. My own experience, and in looking at the results that come out of these processes, is that they're not necessarily all that good. And the tool perspective, I think, is the perspective that has the greatest payoff. Avram Miller of Intel, in an interview, said, look, in this business, we're tool makers. We're not artists. But you know, being a tool maker isn't a bad thing. Tool makers make things possible for other people. And that's where I want to leave you, is go out there, make things possible. Thank you very much. And Cope, this is for you.